yeah, I've been working on a distributed application here, and yeah, like we can get started. So what we're going to see is on orchestrating workflows the temporal way. Uh, so I think most of us would have worked on distributed systems, or at least the term, we are all excited by the term microservices, right? But what in microservices doesn't excite us? Like, what are the problems like most of you would have faced while dealing with microservices? Like, I mean, not from an infra perspective, but from a development perspective, while writing code, like I'm sure like many of you would have come across situations where you have thought, okay, maybe this would have been easier if I was just doing on a monolith or a very traditional way of coding, or like even some of them could be challenges even traditional way and the microservice way. So I mean, just I mean, anything that comes to your mind which you have faced while working on distributed systems or what we call as microservices. Anything you have faced or you've felt this. I mean, is there a way I could abstract this, or is there a way where I can simplify this? Like anything that can, I mean, anything any of you can say about this, like anything that comes across your mind which you felt was tough in microservices, with respect, especially, I mean, uh, especially with respect to the coding part, when you're writing code or when you're dealing with transactions or anything like that. Okay. 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 Yeah, so that is more of a responsibility kind of splitting. I mean, that is something like, yeah, I mean, that is a call that, I mean, it's kind of a clean code practice where we kind of abstract out the calls, the common calls. But apart from that, like, I think maybe I'll just uh, go into it. So some of the problems that like so in we face in distributed systems is consistency across systems, right? So when I mean consistency across systems is in traditional monolith applications, right? So when we are dealing with database operations, I'm sure most of you would have used the transaction concept, right? Where you begin a database transaction, do multiple things, and then you commit at the end. And if at all there's any failure in between, you roll back, right? And once we kind of broke this monolith architecture and went into the microservice architecture, right? You had individual services and you had individual so DBs talking to that services. So if you want to maintain this consistency across systems, right? How would you? I mean, so that was a, I mean, that was a challenge that a lot of, I mean, that we faced in distributed systems, where we worked on, and I'm sure like some of you would have come across this. Like if I was writing this in a monolith, I would have just started a DB transaction. Done all my things and then did a commit at the end. In between, if I face a failure, I just do a rollback and exit. So, so when you want to maintain this consistency in a distributed system, right, in microservices, so across, suppose you're doing a particular operation in a microservice, and that microservice is again calling another microservice for doing an operation, and in between, if there's a failure, you want to kind of roll back multiple things that you did in across microservices, right? So that becomes a problem where you have to write a lot of code to like kind of roll back things in the other microservice, handle things in your, I mean, the originating microservice and those things. So your code, I mean, lot of that logic you will have to build it in your code. And yeah, again, handling retries as well, right? So I'm sure most of you would have written code like if retry attempts less than max attempts, keep retrying, and then once the max attempts reaches, throw an error. So there will be a lot of scenarios in your I mean, business requirements where you will have to keep retrying for till a particular point, and then you will have to throw an error, or sometimes you'll have to keep retrying indefinitely. And yeah, state management. So with microservices and especially with modern day deployments, right, where we have kind of moved to a containerized way of deployment, and we have Kubernetes and whatnot. So where we keep our applications stateless, right? So in terms of that, the state management, when you want to kind of maintain some state, right? Uh, so how do you maintain state? So then we have to bring in another additional infra. We have something. I mean, we use Redis. Sometimes we use the database itself to maintain the state. And if you want to kind of persist state among services and like use it, right? So then we bring in, as I said, we bring in a more infra where you use a database, or in a lot of cases we use also Redis, where we temporarily store the data, store the state, and then reuse it at a different point. And also replay and retriggering tasks, right? So suppose you want to kind of retry or replay a particular task, and also scheduling a future task. So so generally you do some action, and then probably after some time you want to trigger another action, right? You want to trigger an email, or you want to trigger a SMS, right? Some certain SMS will be immediate. So suppose you want to trigger something at a later point in time, you would obviously do something like a cron or other things, right? So those are again like additional tasks you would be doing. So, so to avoid, I mean, to overcome these kind of challenges that we see in distributed systems today, or microservices that we call, like we have, so I mean, I'll just take a small example here, like what I was explaining, right? So suppose you have a bank transaction, and suppose from your originating service, you want to kind of do a bank transfer. So bank transfer basically involves withdrawing from the source account and crediting to the destination, right? So in this, so if you want, so this is like a basic code where this will do a withdraw and a deposit, right? Now if you want to bring in multiple things in this, so suppose you want to add retries for withdrawal, suppose you want to add retries for deposit, you want to reverse the withdrawal if the deposit fails, and you want to configure multiple timeouts, right? uh, so you will have to put in all the code yourself here. So I mean, how, so a simple code like this is what you would want to put in, where it will kind of remain clean, your test cases will remain clean, and you will also anybody reading the code would kind of understand this, and even you would be able to go and make changes in future. But once you start adding all these things, like once you want to handle with I mean retries, once you want to do reversals, and then once you want to like have multiple kinds of timeouts for multiple things, the code kind of gets bulkier, right? So I mean, I don't want to get too much into it. Just a overview of how the code would look once you kind of do all this, right? So here you would be kind of handling the retries for withdraw, and then if there's a failure, you would do. So if there's a withdrawal and failure, you would deposit again, and then you will have to configure timeout. So whatever was so simple on 2 lines, right? Where most of the business logic is. So your entire business logic for your bank transfer is basically withdraw and deposit. But once you want to add all these things, once you want to have retries for your actions, once you want to have reversals, right? You put in so much of code which has nothing to do with actually the actual business core logic. So you have to kind of had so much of I wouldn't say boilerplate code, but this is so much of engineering effort which you'll have to put, so much of tests you will have to write for this, so much of unit tests you have to write, so much of things you have to ensure. And also the code doesn't I mean it takes some time to understand when you write code, like I mean when you have such a code, when you want to kind of explain to someone, it takes time why you are doing this, why you have a retry, why I mean and all that. And yeah, so as I said, it becomes, I mean, for you to kind of handle all this, it is kind of a too much of an overhead, and also the testing effort and everything kind of increases manifold. So this is where I think when we had such problems, like there were multiple solutions. I mean, not multiple solutions. Like I mean, as developers, we try to find solutions so that to make it as modularized as possible and to handle such things. All right. And now what I say, we have a tool that kinds of solves this for us, solves all the problems that I've shown you now. We have a tool that I'm saying as Temporal, which was created to solve those challenges which I've just shown, right? So Temporal kind of guarantees the successful and correct execution of any failure function or service in the face of any infrastructure failure. So what that means is like with Temporal, you can configure retries for any activity, for any workflow. So what are workflow activities? I'll come into it, but yeah, so Temporal will help you to kind of replay certain workflows, replay activities, and kind of if anything fails at a particular point, right? Temporal will kind of pick it up. So once the application comes back, Temporal will pick it up from there and kind of replay it and take it to conclusion. And similarly, yeah, every execution is recorded. So what happens is for every activity or workflow, the Temporal also maintains the state. So which makes it easier for it to kind of replay from wherever it has stopped, or execute from wherever it has stopped. And also it kinds of gives you features for implementing kind of a saga pattern, right? That is what we saw in the bank example, right? So if if your deposit fails, you have to, sorry, if your deposit fails, you have to reverse your withdrawal. So with temporal, it's pretty easy to configure something called compensation activities. So for every activity on the workflow you define, you will be defining a compensation activity, and that will kind of take care of, and temporal will take care of what to do. So when there is a failure, it will take care, it has to do the compensation activity again. And then when there is a failure, it will know when to do a retry. All that you will be configuring when you define your workflow and your activities, and temporal will just take care of the rest. So basically, it abstracts you from writing all those extra code, where you will be writing, if this fails, keep retrying for this many times. If this fails, again retry till it reaches a max attempt. And then if this fails, do this. If this fails, do this. And all these things you will be writing in your code. Rather, with temporal, you will just be configuring all this. You will just say, this is what, so this is the bank withdrawal. This is a function for bank withdrawal, I mean, money withdrawal. This is a function for reversing the money withdrawal if that fails. So you will configure to temporal, and temporal will basically take care of that. So once you provide this configuration, temporal, when you throw back an exception, when you throw back an error for a particular activity, temporal will have that configured that, okay, this has failed. Now, as per the configuration, I have to replay this. Or as per the configuration, I have to retry X number of times. So temporal will automatically do all those. It will do the retries. It will do the, it will do the replay of certain activities, and it will also manage the state that needs to be maintained between multiple activities or multiple services. And yeah, so the underlying infrastructure for all this. So basically, I'll come to the overall infrastructure of temporal, but to achieve all this, it has some infrastructure, it has some queuing, it maintains some persistence. So all this is abstracted basically from the developers who are actually coding the business logic of the application. Yeah, so again, like insisting on what kind of said in the previous slide. So ensures any process or series of events that you start executes completely and maintains correctness no matter the complexity. So again, pretty much the same thing. So you as developers, it kind of uh, uh, enhances you to focus more on the business logic, covering the logical parts of the application, and rather not worry about the other parts of the workflow, like what you have to do in terms of failures, or what you have to do in terms of retries or timeouts and all that. So maybe we'll, yeah. So we'll get into the architecture. So basically, temporal, it has mainly a workflow and a activity. So when we call workflow workers or activity workers, workers in temporal are basically your microservice or your application. So the application that you deploy, where you have written the temporal code, is basically the worker. And temporal also has a server. This is a temporal server, which you will be deploying separately, and you will be giving some persistence. So temporal currently has support for multiple database servers like Cassandra, MySQL, Postgres, and SQLite. So you will be deploying these DB servers, and you'll be configuring that as part of the temporal server. So this temporal server deployment is separate, and this is basically your application deployment. So your application will act as a worker, and the temporal server is a separate deployment. So whenever so generally, workflow workers and activity workers can be part of the same application. Your same application can have both the workflow and the activity. But if you want to like separate your concerns, and if you want, as I said, your activities will be across distributed systems, right? One microservice might have one activity, another microservice might have another activity. One microservice might have the actual definition of workflow. So you can have, so your basically all your microservices will form the workers, be it the workflow or the activity, and you will have a separate deployment for a server, and they have something called a front end server, which basically interacts with the worker. So the worker server interaction is also maintained by, it is handled by temporal itself. So temporal has a lot of support. It has SDKs in Java, it has SDKs in Golang, it has SDKs in Python. So the communication between the worker, that is your application, and the temporal server is taken care by the SDKs. So it uses gRPC internally to communicate, to do the communication between the worker and the server. And it also provides a UI where you can actually see So that's where the observability comes in. Like we have Jaeger for tracing. The temporal has tracing support as well. But apart from that, temporal itself gives you a UI where you can see what has happened in your workflow, what each activity has done, and what has been the output of your workflow. So maybe like, yeah, I'll come to that. Maybe I'll show you a simple workflow towards the end. But yeah, this is architecture just to give a sequence of what happens. So as I said, the temporal workers are your application. So whenever your application encounters a temporal workflow, it informs or activity, it informs the temporal service that there is an activity which I've encountered. So it stores the event for that activity in the DB, and then it schedules the activity in something called a task queue. And the worker picks up again, it picks up the activity from the queue. So this worker, right? So as I've shown you, your application, you will be scaling it as per your requirement, right? So any worker can schedule an activity and any worker can pick up. So whichever worker is free will kind of pick up the activity and execute the activity. And once that activity is executed, it'll again inform back temporal that the activity started and completed, and that is kind of stored back in the DB. So in this whole process, like temporal, when it schedules an activity, and if it has not received back the started and the completed event, after a particular timeout, it will try to again do the same thing. So in case your worker faced faced any downtime, it got crashed due to any infra issues, it will not be able to send back this activity completed. So temporal service, what it does is it sees that it has scheduled an activity, but it has not got back a started and a completed event. So what it will do is after a particular timeout, it will try to redo the event again. So that is where that is where temporal provides that fault tolerance, where in case of any downtimes or failures in your worker, it will replay the complete workflow from start to from start to finish. And that is why it requires your workflow logic to be kind of non-deterministic and idempotent, where even if the same workflow is replayed again, the worker should not, the code should work as expected, and it should not be doing any other side effects. Uh, right. And yeah, in terms of your workers, right? So you will have a particular workflow and you will have activity. So for each workflow and also at each activity level, you will be able to define the timeouts, and also you'll be able to define the retries. Right. So maybe I'll just go to the code once. So if you see here, this yeah, same similar the bank transfer example, right? So here you will be kind of creating the workflow. So all this is provided by the Java library itself. So you will be creating a workflow, you will be assigning the queue, and here, as I said, you will have options to set. Yeah. So as I was saying, so here you will be configuring the workflow. So workflow here in the banking example which I showed is basically the bank transfer. So whatever steps are involved in a bank transfer, everything is encapsulated as a workflow, and each step will be an activity. So for us, the workflow is going to be a bank transfer, and here you can, as I said, you can configure. So all these are provided by the SDKs that are there for each of the programming languages itself. So you can set the retry options, how many ever times you want to retry, and also you have options to set the timeout. So you will have timeout option. Just 1 minute. Yeah, so you will have the task run timeout, task timeout. So different kinds of timeouts you will be able to configure. You'll also be able to configure the retry. So this you can do at a workflow level as well. So as I said, the fund transfer is if you consider as a workflow. For the workflow completely, you can set retries. That is, if the entire workflow fails, you can set retries. And for the entire workflow, you can have a timeout. And now going in, so this is so the fund transfer becomes a workflow, right? So what constitutes an activity is yeah. So each of this becomes an activity. So for the fund transfer, withdraw is an activity, deposit is an activity. So maybe in real life or in practical cases, there'll be maybe many more activities you define. But as I said, like this is an activity, withdraw is one activity and deposit is one activity. And at an activity level, again, you can define. So here you are configuring activities. So as I showed you for the workflow, again, you'll be able to set the set retry options and set the timeout as well. So you will have to set start to close timeout. So as I was saying, you have options to set retries and timeouts at workflow level, and you also have options to set retries and timeout at a particular activity level. So this amount of abstraction Temporal is giving you so that you don't have to code any of this. You don't have to write any retry logic. You don't have to write any timeout logic. All that you have to do is just configure, and Temporal will take care of all of that out of the box. And one other Saga pattern which I was telling, right? So that is basically the compensation activities. So that again, there will be an example. Just give me a minute. So this is the kind of a Saga example which I was saying, where again, the Java SDK, the temporal gives has a Saga class. So for each, so if you want to handle that kind of cancellation activity as well. So here for every activity they have defined, they would have configured a cancellation activity as well. So for reserve car, there's a cancel car. For book hotel, there's a cancel hotel. For book flight, there's a cancel flight. So if at all in any of this process there's any failure, all the compensation activities will be triggered, and and finally the workflow would complete. So, so that is why it first asks you to configure the cancellation activity. So even if your first activity fails, it will call the compensation activity. So whatever you define in the compensation activity should be able to handle such calls. So that is, I mean, that is what Temporal expects you to do. So once you define, once you configure this at the workflow level, right, for each activity, you will be giving a compensation activity, which is what needs to happen in case of failure. And you will have to define, you have to basically implement all these activities. So as I had shown previously. Yeah. So you just have to kind of implement all that. So for you'll basically have to implement book flight. You will have to implement cancel flight. You have to implement reserve car. You have to implement cancel car. So for all this, you will be writing your business logic, just your business logic here. And Temporal will take care of, as I said, the retries, the timeouts, doing the compensation and all that. So this is what kind of at a very high level Temporal provides. There are a lot of other examples as well where Temporal gives you an advantage. So as I was saying, right, so you will be able to kind of do delayed activities, right? So suppose you do a send welcome email, and then you can do a workflow.sleep for 30 days. And then after the 30th day, you can charge a monthly fee. So this is just some random example. But these are things also possible with Temporal, where you can say workflow.sleep, and Temporal kind of maintains maintains the workflow in its own cache. Again, as I said, the underlying infrastructure is abstracted away from you. Temporal maintains the workflow in the cache, and it will be able to resume this after 30 days and charge the monthly fee and all that. So you don't have the business of writing any crons or other bad jobs here. The workflow should take care of doing all that. You just have to configure all of this. And yeah, whatever we've been discussing, the task queue, the routing, the timers, uh, pretty much. As I said, the underlying infrastructure is abstracted by Temporal. Mm, yeah. No, this. Yeah, yeah. Yeah, so as I said, the underlying infrastructure for the temporal part, right? How it kind of queues the things, how it kinds of maintains the thing in the DB, how is it able to maintain the metadata, queue it, or cache even the workflow? Those things are abstracted, but as I said, the workers that are a part of temporal, that is your own microservice. So this infra, you still have to maintain it. If there's any failure, like you will have to kind of look into it and we will be responsible for bringing back the worker. But once the worker is back, temporal will be able to replay whatever workflow was not completed. So so if your application crashed in between doing a workflow, so that workflow is incomplete. So temporal will have a record of it. And once you fix whatever infra you had issue and you bring this back, temporal will kind of replay it and kind of complete the workflow again for you. So the underlying infra, so basically the queuing and all that, right? This queuing and also maintaining the data, those kind of infrastructure, and even for the temporal service, it's kind of abstracted from you. But your application and the microservice which acts as a worker, all that you still have to maintain. And even the DB, like you will have to provide that DB to temporal. This one? Yeah. Yeah, so if temporal server itself fails, right, then again, temporal so basically the server itself is built to scale. It can scale along with your worker for millions of transactions. But if there is any underlying infra downtime or something, where even it causes the temporal server itself to crash, then you will have to bring it back. And if there is any workflow that is pending, it will still be able to replay it. But again, if the server itself crashes, like, yeah, because your infra had some issue or something, yeah, you will have to bring it up. It cannot come back on its own. Hmm. No. Yes, you can. So it will be a single temporal server will be single, and every microservice you will be configuring the kind of the host and the port, and it will be able to connect to the same temporal server. So basically, as I said, right, so it has something called a task queue, right? So so you can have multiple workflows in your business use case or in your application, because as I showed, fund transfer is one workflow. So banking application can have multiple other workflows. So every workflow, you can have a separate queue name, and your activity should also be mapped to that queue name. So as in your Java SDK, you have annotations for all that. So while defining a workflow, you will say this belongs to this fund transfer queue. And even while defining your activity, you will say this belongs to the fund transfer queue. So if there is any activity that is scheduled in the fund transfer queue, any worker that is capable of handling the fund transfer functionality will pick that. If there's some other thing, right, book and FD, if that is the workflow, that will be with a different queue name, if book and FD queue name, and whatever activity is configured to kind of pick up the book FD, this thing, right, the queue, it will pick up that and it will execute that. So you can have any number of activities or any number of workflow, but everything will kind of connect to the same temporal server. Yeah, yeah, you can, yeah. No, no. So all that, so yeah, the load balancing for its own services, temporal will be able to do automatically. As I said, your logic will still be with your application's microservice. All that abstraction, right, which the retry how to retry, how to time out, how to replay, all that temporal configure, all that temporal server will take care. But what the business logic that you have to do, what your activity has to do, will still be with your application microservice, which will act as a worker. Yeah. Hmm. Yes. Yes. Temporal. Yes. 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 Yes, yes. It is by default it is synchronous. If you want, you can make it. You have again, you have methods in your SDK which you can make it asynchronous as well. So if you're probably running a job, I mean background job or something, that you will maybe not need it to be synchronous. Though those things you can make it asynchronous, but by default it will be synchronous. Yes. Yes. Hmm. So as I said, Temporal has support for open telemetry and also it had support for open sensors and tracing. So you can configure your open telemetry interceptors when you set up your temporal workers and temporal the queues, right? When you're setting, I mean, when you're as part of, you will have SDK methods where you will set up the temporal worker here. So in that you can provide your open telemetry interceptors and temporal will take care of that. And I mean, we have seen this, I mean, we have not yet productionized it for a use case, but like we have seen this in our lower environments where it is able to show each workflow, what activity it executed, and also any other network calls to other services. It's able to show that, all that. Yeah, yeah. Yes, yes, it can be parallel as well. It can be parallel. It can be parallel. Yeah, yeah, you can. That's all. That flexibility is there. And coming to tracing, as I was saying, right, temporal itself gives you an UI. So if anything fails, you just have to put in the, as you have a trace ID, you'll just have to put in the workflow ID. Just yes. No, that is what that is. It is. It will not become a bottleneck. So it has no kind of chance to goof up, right? Because this temporal server is something you will deploy once and you will leave it that way. So you're not going to make any changes to the temporal server. It's already done. You have a Docker. I mean, you have a Helm chart as well, which you will just take it and deploy it, and you will not make any changes there. So whatever application logic you need, you will be doing that and you will be using temporal. And again, as you said, right, so this, I'm not saying that you go today and change all your APIs or all your journeys to temporal, right? So you will have to look at your workflow. If you have conditions where you have been writing too many retry logics, too many cancel activities, and also you have I mean, you have requirements like a cancellation rate, where if particular thing fails, you have to go back to another service and kind of roll back that. So in that cases, this definitely will become a lot of use where it has that saga pattern inbuilt within itself. So yeah, it depends on use case, and yeah, you will have to evaluate your journey or your workflows in your application and see if temporal can help your use case. So as I said, like you will be you will be kind of provisioning a DB for temporal, right? So temporal will kind of use that to manage the state. So whatever metadata you need to pass between two activities, right? So if you have a, so suppose you have a withdraw activity, deposit activity, if you want to pass any data between those two activities, that will go to temporal, and temporal will have it in its DB, and then it will come out. Hmm. 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 So no, it will you. I mean, you will be able to receive the logs in your code as well. So probably. Uh, so basically, so when you start an activity or a workflow, right, or when you have an overall workflow, you will definitely have a exception handling, or so in Java, you will probably have a catch for the entire workflow trigger. And then if there's any issue in the workflow, so suppose you have configured your workflow and you have given 3 retries, assume. So it is failing even all the 3 times. And then, so it will not retry post that, and it will complete the workflow. It will say it is failed, and you will be able to, in the catch block, you will get the exception. So whatever you need to do based on that exception, you can still do. So if you want to throw, I mean, if you want to send some error to the client saying something bad happened, you can just put it there. Yeah, yeah. No, our application only. So, so as I said, right. So the worker executes. So worker is basically, as I said, it's our microservice that we deploy that executes the activity. Temporal just orchestrates it. It tells what activity should be picked, what should be picked first, what should be picked next, what should be picked in parallel, what should be picked after, what should be retried, what should be kind of compensated, and all that. Hmm. So basically, so if you see the code, right? So whenever, so suppose you are calling this reserve car somewhere, right? So when it encounters an activity method, so basically the workflow will, basically your worker will tell I've encountered an activity to temporal. Temporal will kind of put that in the queue, and then again one of your workers will pick that and kind of execute it. Yes. So workers are basically your usual application deployment. So if you have your worker, you can think of it as an HTTP server. The communication between your worker and the temporal service, it's again managed by the SDKs. The underlying protocol it uses is gRPC to communicate between the worker and the temporal service. Yeah, you will be using that SDK in your app. So all this, so if you see here package IO.temporal, sorry, IO temporal failure, application failure, and it will be more evident in the, yeah, all this is provided by temporal, IO.temporal workflow.saga, workflow.workflow, failure.activity, failure, activity option. So all these classes are provided by the SDK itself. And SDK will take care of the communication between your microservice, which is the worker, and the temporal server. Yes. Yes. Yeah. Yeah. So what happens is, so yeah, in the SDKs, there are a lot of new things being added. So what happens is you can do an auto discovery of, you can basically mention the packages where you have defined your workflow and activity in your microservice as a configuration. And once you start your Java or your Kotlin application, right, the SDK will be able to identify your workflow and activity, and it will automatically register that with the temporal server. So you don't have to even manually go and register these things. So temporal will be able to I mean, the SDKs now with the latest updates, it will be able to automatically identify the workflow and activities, and it will go and automatically register that with the temporal server. And during actual execution, when there is any activity to be executed, temporal will say, I encountered this. So the server will schedule that, and one of the workers will again pick it and execute it. Yeah, yeah. So those things, it's up to you. So it can be integrated with anything. Uh, Basically, you have to, as I said, workflow and activities form the core of temporal. So you have to define your workflow, you have to define activities, you have to register that with temporal. And as I said, no, SDKs with the modern packages, they are able to automatically register. You just have to mention the package. So once all that is done, it will get registered. And whenever so you will have to write the code basically for initializing the workflow. As I said, you configuring the workflow here, configuring the activities, and you will have to give if it's Java, you just have to give annotations, and it will be able to identify that this is a workflow and activity, and your temporal server will be ready to start the orchestration. And once in the actual execution, once it encounters uh, an activity execution, it will say to temporal server that I've encountered an activity. Temporal will put that in the queue, and our worker will again pick that and execute it. And once it's completed, it will communicate back to temporal saying that I've completed this. And yeah, the workflow execution stops. And if that communication doesn't happen after a particular timeout, temporal will again schedule it and try to ask one of the workers to pick it. I scheduled this workflow, but I have not got back a success. So I waited for this time. Now I'm going to replay it again. Since I have not got a success from your worker, I'm going to trigger this again, and then it will get triggered until it get back some status back from the worker that this is failed or timed out and anything. It will keep trying to replay the same workflow.
For the replaying, right? At what point will it know from this particular column and it will make?
So it will have all that state maintained in the DB, right? So it will have as part of this workflow, I have completed 2 activities. I have completed uh, booking a car, booking a hotel, but flight booking is not yet completed. I have not got back the response from the worker. So it knows these 2 things are completed, but the final part is not completed. So it will try to schedule this again for the same workflow and try to do it again.
There also needs to be handled by the application.
Yeah.
After retries, my payment service didn't go through. The reversal of the transaction has to be handled by the application.
Yeah, so you will have to define that this is what my reversal logic is. Basically, if you want to reverse, you should know like which table to delete it from or something. So that logic you will write and you will just configure that here. This is the compensation activity, and temporal will take care of scheduling that activity and asking the worker to pick that. So if the reversal also fails, so it will try to keep doing that. So after a particular point, if it still fails, yeah, I mean in that case, you will have to. So that is kind of a this thing where it will keep trying to redo it. Mm-hmm. Yeah, yeah. So you, it should be there, but like maybe I'll have to explore more on that. You will have a workflow ID, so you can go use that ID to go and see in that temporal UI what happened to that workflow, basically.
This complete aspect of retries and error handling and all those things. So it is, I mean, is this functionality or is this SDK only applicable for distributed systems? Like it can be used for monolithic also. Because the monolithic
Yeah.
also can have.
You can use it for monolithic also. So as I said, the workflow and the activity can be part of the same the same service also. It doesn't have to be distributed. If you want, you can use it. If you have a use case where you want to use it, you can use that as well. Yeah, you can use. And and for the retries and other things, you can also configure exclusion rate. Do not retry or do not fail for this kind of errors. So certain business errors, you know, how many ever times you retry, it will still result in an error. So you can still give those exclusion blacklist also. You do 3 retries, but for this, if this is the error, if this is the exception that the program is throwing, you don't retry for that scenario. So reversal is a choice. So if you have a reversal requirement, you can have a reversal. Retries also is a choice. You can say 0 retries also. So this thing, but when you have retries configured, you can also have an exclusion. You can say do not retry for this exception. Hmm. Hmm. Yeah. Yeah. It will do. Yeah, every time it will do. Yes.
All the retries, it will do the reversal. Or for every
Uh,
retry.
no. After all the retries. So at an active. So at an activity level, you will have retries. So if after all the retries it's still a failure, it will do the reversal. So like, I mean, final part is, yeah, deploying temporal in production. Like for the temporal server, you have Helm charts, which you can deploy, and it has support for multiple database servers. So you will have to provision a Postgres or a Cassandra instance, and then configure that in the Helm chart, and get it deployed and running on Kubernetes or whatever environment you have. And as I said, it has support for tracing, and it also provides a metrics endpoint, so you can have a service monitor defined, and you can see the complete thing in Grafana. You can see the resource utilization. You can see what all is happening in the infra of temporal server as well. They provide a metrics endpoint, so all that is available. So yeah, any other questions? Yeah, it is open source as of now. So basically, I mean, if you guys are aware, Uber had a had a product called Cadence, which was kind of doing similar thing. So the founders of Cadence so basically the tech lead of the Cadence project in Uber came out and has started this company Temporal, and they have evolved it much more from what Cadence was, providing more support on SDKs and a lot of other things like tracing, metrics, multiple database servers, and other things. So yeah, I mean that there's a lot of history in that of that person who started the company. Like he was first, I mean he was in Uber Cadence, the tech lead, and then previously he was with AWS where they did the SWQ. So yeah, I mean you guys can go and read about it. No, no, Java it's there. Java, Go, Python. .NET, I'm not sure. You'll have to check. Okay, so .NET you'll have to check. Any other questions?
All right. We are done. No more talks for the day. But then I'm just gonna nudge you